A friend of mine had a problem recently. Somebody has gained access to his basement and took some of his stuff without approval. How rude. So today I will show you how to build a simple alarm system which produces a loud and annoying sound when somebody tries to enter the door without permission. The special component of this system will be a reed switch. Now what the hell is a reed switch? Basically it's a switch which closes when a magnet is near. Here's a simple example with a LED. The magnet comes close, the switch closes and the LED lights up. And when we move the magnet away, the LED turns off. Such a switch is not made for high currents, but we only use it to detect whether the door is closed or not. This way it only acts as an input for the microcontroller, and that means practically no current will flow. Another input will be a key switch and a push button. The key switch is pretty easily explained as well. Turn green, switch closes, LED lights up. And turn red, switch opens and LED goes off. And I will use two buzzers which produce horrible sounds. One works with 12 volts, the other with 6 volts. But I think if I ask nicely, both will work with 12 volts. So this locks us with a 12 volt power supply. At first I tried to use this linear one. You know, the old ones with huge heavy boxes. Inside we can find a transformer. And no, there is no Megatron inside. Sorry. And this transformer transforms our 230 volts AC to around 14 volts AC. Then we have a bridge rectifier. Basically 4 diodes which turn our AC form in a DC form, and at the end a big smoothing capacitor. Really easy to build, but efficiency is horrible. More about that at the end. Okay, let's take a look at the other parts. One LM7805 and capacitors to supply nice 5 volts for our microcontroller. One BC547 transistor with a 1K resistor to turn on and off our lovely, absolutely not annoying buzzers. One RGB LED, which was a total overkill because I only used the red LED inside. This guy will notify us later when it is safe to go in the basement. And some more resistors as pull down resistors. You can find all schematics, code, layout and values for the resistors, capacitors and so on in the video description. Let's build the circuit for now. I even did the outstanding this time and made a circuit board layout for you. But this circuit is pretty easy to do. The most difficult part is actually to connect the external parts to the PCB later and not screwing up while doing that. Okay, PCB looks good. Notice those little female headers. That is where we have to connect external parts. And there are quite some of it. I used this case you normally find when you do electrical work around your house. The front gets a round hole for our LED and a square hole for our push button. And 2 more holes for the 2 buzzers. I used mostly a Dremel and rasps. Now I have to connect wires to each and every pin of those 4 components. And don't forget the male headers. I also soldered male headers to the reed switch and the key switch. Last step would be to combine the external parts with the PCB. The schematic tells you pretty good which wire goes where, but I think here it is much easier to see where to connect which part. I already programmed my ATtiny when we headed for the basement, but don't you dare to forget to program your ATtiny 85. Without a program nothing will happen. My friend and I secured the reed switch and the magnet near the door frame. We also secured the key switch somewhere not too visible for intruders. We secured the case over the door frame, and again I connected all external parts to the PCB, and it really can be distracting when the male and female headers do not really fit nicely. But it worked in the end. Now let's take a look at the code and compare it to real life. It is really easy. Firstly, the device gets power. Now the ATtiny is waiting for someone to press the button. Otherwise the LED will blink forever and the security system will never be active. Now you press the button. There are 2 things that can happen. The key lock is green or red. If it is green, everything is okay. You are the owner and allowed to pass. The LED shines red to let you know. But if the key switch is red, the security system is active. When the door is closed, nothing happens and the LED is off. But if someone opens the door with violence, the buzzers will scream for 60 seconds. Afterwards, the LED blinks again and needs to be reactivated. That is the whole process. Another important fact is power. How much does this cost if it works 24/7? With the linear power supply I got around 14 milliamps. 230 volts multiplied by 14 milliamps equals around 3.22 watts. 24 hours multiplied by 3.22 watts equals 77.28 watt hours per day, and 77.28 watt hours multiplied by 365 days equals 28.2 kilowatt hours. And with a cost of 29 cents per kilowatt hour, this costs around 8 euro in 1 year. That is kinda pricey. I tried a smaller switching power supply and it only draws 4 milliamps. With the same calculations it costs around 2.3 euro. That is much better. As always, thanks for watching. Be sure to watch some other projects I did in the past, and you can also follow me on Facebook, Google+ or Twitter. And I will see you next time.